How do you fix a left or right tear if you're paper tuning? Right. Well, the math behind it is, let's say that you've set it up and you're getting a left knock tear. So your point is coming into the paper on the right, your knock is coming in on the left. What that means, it's not so intuitive, but it means that your power vector is pointing to the right of your arrow. Now they could be really close, right? These adjustments we're making, it's not off far. If it's off far, you might see the arrow do something really kind of wonky. But we're saying they're close, right? But not perfectly aligned yet. So what happens is if that power vector is a little bit to the right, and this has been shown in slow motion, this, as that arrow rest drops away, then your arrow comes forward, the rest drops, you get this force pushing it forward, and that tip, the heavy tip, swings towards the power path, and your fletchings will kick out to the left. And it's been shown on like slow motion, you can see the arrow doing this. Now it's specific to a drop away rest. If you have a whisker biscuit, it may not work exactly the same. And so with the whisker biscuit, if you hear someone say like, well, I had to move my rest the opposite way that I'm explaining to you, well, it might be because they're using a whisker biscuit or something else is off. But typically that's what happens is that arrow, if the power path is pointing to the right, then that arrow will fishtail and kick out here to the left, and you get a left tear. So how do you adjust that? Well, if you're adjusting the arrow, you want to move the arrow rest to the right so that it gets the arrow lined up back with that power vector, right? So tail left tear, you want to shift your rest to the right. Same, it works exactly the same if your power path, which you can't see, right, that's coming off your string, is to the left, then that arrow is going to swing, the tip is going to follow the power path, and your fletchings will kick out to the right. And so you would want to move your rest to the left in order to get your arrow to line up with the power path. That's one way to accomplish it. Now I personally don't do that because I get my arrow right in the middle of the riser where I like it, and I would rather adjust the power vector and leave the arrow alone to accommodate for the left and right tears. So how is that accomplished? That's done up here through the cams. So let's go back to the situation where we get this tail left tear. Our power vector is pointing to the right of the arrow. That means I need to get this power vector straightened out. So I need to bring the back of it over here to the right. How am I going to accomplish that with my cams? Well, I need my cam to lean more this way, right? It's got to bring the string over so that it can straighten out that power path and bring it behind it. Let me bring it back behind here. Okay. You can see that that cam is slightly tilted at rest here this way, right? Because I had to bring the string down more to the right to correct that. Same with on the bottom cam, you'd want to lean more this way, right? So top cam's going to lean this way, bottom cam's going to be this way. Now we're not talking a drastic lean. When you get to full draw, it should look like it's coming straight down off of the cams, right? So how do you get your cams to lean like that? Well, that depends on the bow that you've got. The method that was used for a long, long time is just shimming the cams. Okay, so you actually shift the position that this cam is between these two limbs. Well, which way do you want to shift it? This is also kind of counterintuitive. The two limbs on your bow are pulling up. So if you increase the distance between the cam and the limb, that provides more leverage for that limb to pull on, and it will pull harder. So we want to increase the distance between the cam and the right limb. So we need to shift this cam to the left, meaning I'm going to make this spacer smaller, and I'm going to put a bigger spacer in this side. That will result in the cam tilting more like that and should fix that left tear. right? All right. In this particular Hoyt bow, it's got yokes on the top. So you can also accomplish this lean by just putting a twist into this left yoke and taking a twist out of the right yoke, and that will start tilting it for you, right? So didn't need to actually shim this top cam to accomplish that. Sometimes that's not enough, and rather than just continuing to tilt and tilt and tilt and tilt this cam, you don't want to make it too tilted. You can go to the bottom cam, and you can shim. This doesn't have yokes on the bottom. It's a 1.5 system. So you can just put a smaller shim on this side, a larger shim on this side. Once again, that will allow this limb to pull down harder, have more leverage, and so it will make your cam tilt in like that, right? Which is what we want to fix that left tear. It's the exact same thing if you're getting a right tear. If this fletchings, they kick out this way and you tear to the right, well, you just need to straighten up your cams or tilt them the other way. So I would twist this yoke and untwist that one. So that's how that system works. A lot of bows used the shim system in order to get that cam lean in there. Now the newer bows like Darton came out with a system where you put in a screw on the front end of this limb, and you increase its poundage. So if you're increasing poundage on this limb, it will pull harder up and it will cause that cam to tilt like that. So if you get a left tear in a Darton bow, you tighten the screw on this side of the limb. If you're getting another tear, you would tighten this limb to make it turn all the way. Hoyt does the same thing. Hoyt's new system in 2026 was you screw a little wedge in that increases the pressure on the limb. So you're just increasing the poundage of one of the limbs with their system, same as the Darton one. And if you increase the pressure on this side, the cam will tilt a little bit that way. Same with the bottom, you increase the pressure on that and the cam will tilt a little bit that way, right? It's really nice because you can make those systems symmetrical very easily. You put in one twist in the top, one twist in the bottom. You can get your cams to lean the same amount on the top and the bottom. Mathews uses a system where they increase the distance between your cam and one of the limbs. Again, as you increase distance, it allows more leverage for one of the limbs to pull up on. So if you increase the distance here, move the cam that way, it'll tilt this way with the Mathews system. Same with the Bowtech. The Bowtech system is the same way. It makes this cam move back and forth between these. And again, if you move it that way, this has more leverage, and so it tilts like this. I think Prime and PSE and the other companies, they're still using the shim system, which works really great to move the cams. Every single one of those systems, though, the point is to affect this cam and the bottom cam to shift the string so that it affects your power vector. One other option that you see on some bows, the new Darton Tritech has it, is this cable guard. You can shift it left and right. What effect does that have? Well, if you shift it out more, it actually pulls down on this cam and it straightens it out. So if you are getting a left tear, that means we'd want to take the cams and get them to tilt more like this, right? And so you would need to take your cable guard and you need to move it to the left. So left tear, move your cable guard to the left. That is going to allow that cam to tilt more this way. If you move it to the right, it actually straightens the cam out, right? So that's another mechanism. But every single one of those mechanisms is to affect how the string is coming off the bottom and the top cam. All of them affect that. And that is how you tune it. I mentioned that that's what I like to do before I start messing with the rest. It's because I like my arrow to be lined up right in the middle of the bow. And so I use these systems to fix the left and the right tears. That's a starting point. Once you get a bullet hole through paper, once again, you're chasing perfection. In order to get your bow in perfect tune, that's really impossible, but you can get it really, really close. You can get that arrow sitting right in line with this power vector. But I start with the major adjustments using the cams. And then once I get it paper tuned and I start bare shaft tuning or broadhead tuning, that's when I go to the rest, because the adjustments after that are just so minor that the rest doesn't hardly move at all to finish out tuning the bow to where I like it. So that's how you fix a left and right paper tear and the reasons behind it.